Okay, so we would like to show that a certain equation has a real solution, and this is not the type of equation that one could solve in a straightforward way and find the solution. So this has to be done, as we sometimes say, indirectly, meaning without finding the solution, but rather use an indirect argument that establishes that such a solution exists. So what is that indirect argument? Well, it's based on the intermediate value theorem. Let's recall what the intermediate value theorem says, or actually it's true that what I'm going to give here is a sort of special case of the intermediate value theorem, which is sufficient for our purposes and which can be used pretty much in as a general way as the general theorem. So here's what it says. If f of x is continuous on AB, and f of A times f of B is less than 0, then there exists C in the open interval AB such that f of C is equal to 0. And here we should make the remark that this condition here is just a fancy way to say that we can find a negative input and a positive, a negative output and a positive output. So we can find two outputs that have the opposite sign. If we can do that for a continuous function, then we can be sure that the function is has an output equal to 0 somewhere in between. That's the idea here. So first of all, we have to create this function, and the way to do so is to bring, first of all, everything to the left-hand side. So we begin by rewriting the equation as x to the fifth plus x minus 3 is equal to 0, and then we define f of x to be x to the fifth plus x minus 3 equals 0, minus 3, which is a continuous function. It's a polynomial. It's continuous everywhere. So to be able to apply the intermediate value theorem, we will have to find an input where the output is negative and an input where the output is positive. So let's start with the simplest one. I mean, the simplest thing for this function is to plug in 0. So if we plug in 0, we find negative 3, which is of course negative. And now we need to find an output where it's positive. We can experiment a little, but it's very simple to see that f of 2, which is 2 to the fifth, also known as 32, plus 2 minus 3. So this will be 31, which is greater than 0. So by the intermediate value theorem, A will be 0, B will be equal to 2. By the intermediate value theorem, there exists, so by the intermediate value theorem, we abbreviate this as IVT. There exists C in the interval from 0 to 2, such that f of C is equal to 0. Such a C is a solution of the initial equation. And that's all. Thanks for watching.